All right. Hello, everyone. I'm Brett Norton from Beyond Clean, and I'd like to express my gratitude for you choosing to spend your Friday with the speakers and I. You're 100% making our day, and for that, we thank you. I would also like to thank our event sponsor, 3M, for helping to make this educational event possible. The title of this conference is Brushing Up on Quality 2.0, Infection Control in the Dental Setting, and it has been such a great day filled with enlightening and engaging dialogue with our subject matter experts. Our next speaker has become a regular at Beyond Clean events because of her engaging presentation style and her extensive knowledge of instrument cleaning chemistries. Peggy Spitzer is a clinical education manager at Sterile International with over 30 years of experience in the healthcare industry. She develops and presents in-services and educational programs focusing on infection prevention, instrument processing, and best practices for cleaning chemicals. As our enzymatic aficionado, Peggy continues to share her insights at Beyond Clean virtual conferences and exclusive educational content. Is point-of-use instrument care routine practice in your dental setting? Today, Peggy is going to help us explore the best practice instrument reprocessing steps from point of use to sterilization. She will outline critical takeaway methods and chemical factors for effective cleaning at each step of the reprocessing cycle. Get ready to clean up your act because infection prevention is more important than ever. Without further ado, let's welcome Peggy.
Thank you, Brett. That was a great introduction. And yes, I'm happy to be here with Beyond Clean and sharing information with all of you out there. It is, as always, a little strange to try to interact with the camera, but I certainly hope that all of you out there are able to get past that. So as Brett said, I'm a dental hygienist, past dental hygiene educator. I managed dental clinics for over 20 years. Now I'm deep into the chemical world. I am a clinical manager, so this is my disclaimer. I am an employee and clinical education manager for Sterile International. So now I hope to be able to share that combination of knowledge with you, as I've also migrated a little bit more to the medical world as part of our business here. So this program does have a somewhat limited focus. We are primarily looking at instrument processing from point of use right up through rinsing and stopping at packaging. So I won't be getting into the packaging and sterilization parts of it. So yes, it's clean up your act. So we're looking at those best practices for those cleaning steps. And the program objectives, as you can see in front of you, we're going to be looking at those essential resources. Some you may be familiar with, like the CDC guidelines, the standard summary, the newer one in 2016. Some you may not be as familiar with, like ANI-ST 79 and why that's still important to dentistry. And also looking in depth at the instrument manufacturer instructions for use. And I'm really pleased that my friend Nita has been speaking with you and will do more today about the instructions for use. Because in my opinion, this is going to be one of the big game changers for dentistry and instrument processing. So we have two basic goals for instrument processing. That's going to be making sure that the instruments are safe for the next patient. That is absolutely number one. But the other goal is to make sure that our instruments and devices are also preserved. That is, they stay in good condition and they're functional. Now, the other thing we want to do is identify the critical elements and especially the chemical factors. I work for a chemical company. I knew nothing about chemicals. Well, I thought I knew, but I didn't. When I came here to work at Sterile, I really learned about chemicals. And I hope to share just a little bit of those insights with you today. And then we're also going to take a very short look at a few types of methods and tests that can be used in your cleaning process. So this chain of infection, I'm sure many of you have seen before, our classic pathway. We have pathogens. They come from somewhere, and then they do have to have some way of spreading through the air, in moisture, sometimes on a sharp object like an instrument. They find a route of entry, and then they get into a susceptible host. So how does this apply to instrument processing? Well, we know for sure that we have a pathway for cross-contamination with sharp instruments from patient to patient. We have actually seen this happen with certain scenarios that you may be familiar with from the news. So we know that there is patient-to-patient transmission via instruments and devices. And it's obvious that sharp items certainly can do that. But I also want you to think about how invasive dental procedures have become and why this is becoming a more and more effective way, unfortunately, to transmit infection. The other issue we're going to look at very briefly is the issue of transmission from patient to healthcare worker. And of course, this is our safety message, in that you need to process instruments and devices carefully for the sake of patient safety, but you yourself need to stay safe. So you basically have several strategies. There are work practices. Work practices are basically what you have to think about. You have to be conscious of them, and you have to do them. They're very important, but they do require more conscious activity. And those would be things like your PPE, and also the activity where you're doing things one-handed to protect yourself. And we'll see how that plays out here in just a minute. The more effective method of protection is engineered devices. Engineered devices are things that are more passive. You don't have to think about them, they're just there. And this is where solid transport boxes or automated cleaning devices come into play. So anything that can protect you, the worker, from this transmission from patient care to you. I'd also like to say very briefly a word about disinfectants. Disinfectants have sometimes been used in instrument processing, and this is a very chemically related issue. That is, there are some chemicals that are in disinfectants that should not be used on instruments because they may cause harm, and you need to look for this on the instructions for use. But the other issue is that sometimes we are still thinking about using disinfectants as a way to make things safer for you, the worker. And I'd like you to get that line of thinking out of your mind, because we do not use disinfectants to make things safer to handle. We use strategies like PPE and engineered devices. OSHA has nothing in their standard that says you should use a disinfectant for worker safety. Disinfectants have a lot of other good applications, but instrument processing is one of the more difficult strategies that you really have to review. So to summarize, disinfectants should not be your main strategy for making things safe to handle, and especially not barehanded. Okay, let's look at these resources that we have for instrument processing. You may be hopefully familiar with the CDC guidelines from 2003. Those are still very effective and have a lot of good information in them. There is information in the 2003 guidelines about instrument processing that has become somewhat outdated. So be cautious and make sure that you are referring to your instructions for use for your instruments or devices, and that you have thoroughly reviewed the summary CDC guidelines that came out in 2016. The 2016 guidelines also have a fairly short section for instrument processing, but they do highlight certain very important things that I'd like to share with you. The 2016 guidelines emphasize that every office needs policies and training for instrument reprocessing. The 2016 summary highlights the issue with manufacturer's instructions for use as a very important addition. The summary also discusses the issue about single-use devices and how offices are sometimes trying to reprocess single-use devices. It discusses some of the issues about dental handpieces and their reprocessing, and it even alludes a little bit to electronic devices like intraoral sensors. So it is a very important item. Now, I'd like to mention just a little bit about AAMI ST79. And I've had folks from the dental world tell me, well, I don't need that. It doesn't apply to me. So here's what I'd like to tell everybody in the audience. AAMI ST79 is for healthcare settings, not necessarily hospitals. It's for healthcare settings. We in dentistry are in a healthcare setting. So no, you may not have a huge medical washer. No, you may not be doing a Boyd-Dick test. But I will tell you that the AMI ST79 is still a very important resource for dental healthcare settings. And we have folks doing oral surgery and other dental procedures in hospitals. So no matter what, it's a very important resource. But by far, the most important thing that we want you to get into your resource library are these device IFUs. And start with your devices that are more complicated, your more expensive devices, and work your way through, step by step, item by item, collect the device IFUs, read them, and then figure out what the implications are for your processing. So what are IFUs? I think you may have already heard some definitions, but it is validated reprocessing instructions. So the manufacturer of this dental handpiece that you see on your screen, they cannot sell this device to you in the dental office until they have cleared it with the FDA. In order to clear it with the FDA, they have to show reprocessing instructions that do produce a clean handpiece, clean and sterile, and free of a certain amount of pathogenic organisms. They have to contract with labs to do that. It is an expensive process, and it is very complicated. But once the instructions are validated, then that means that you, the purchaser and end user, must follow those instructions to ensure that that device is safe for the next person that you're using it. So the big issue in dentistry, is it reusable or single use? So if the item does not have instructions, it is not reprocessable. It's not reusable for another person. It must have validated instructions. Where we get into a lot of issues are things like burrs, and especially diamond burrs, because they're expensive and people want to clean them and reuse them. Are there instructions? The ADA has been working on helping manufacturers develop reprocessing instructions that can actually work and that an average dental office could follow. We really have kind of two issues with the reusable and single-use thing. We have, unfortunately, dental offices that continue to reprocess and reuse single-use devices. That is certainly a problem. But we also have dental offices using equipment like the controls for suction or certain parts of removable parts of handpieces that have cleaning instructions. They are reusable, and we're not following those instructions. So there's two different aspects to this that we really have to get a handle on. Now I'd like to get into a little bit more about chemicals. So chemicals and IFUs. Now this is a quote on your screen from an actual IFU. Cleaning agents with chlorine or chloride is an active ingredient or corrosive, should not be used. Cleaning agents with neutral pH are recommended. How do you find these chemicals? How do you follow these instructions? That's what we're going to get into here, just to give you a little help with that. So many of you are probably familiar with the pH scale. From 0 or 1, roughly up to about 6 is considered acidic. From roughly about 6.5 to 8.5 is generally considered neutral, at least in the world of detergents and instrument processing, 6.5 to 8.5. And then above 9 and above is considered alkaline detergent. So where do you find this chemical information? You might find some of it on the label, but the vast majority of the information will be on the safety data sheet. So you're going to look in section 3 for chemical ingredients, and you're going to look in section 9 for pH, color, odor, etc. So you need the safety data sheets, and you need to make sure they're the current safety data sheets and that you have the correct name and the correct product. So sometimes manufacturers get a little bit desperate, and instead of just putting it on the IFU or even on the label, they'll put it on the actual product, and they'll actually have little instructions stamped on your device or item saying, do not use abrasive or chlorine solvents, or don't use alcohol. So the manufacturers are really trying to help you to take care of your devices, clean and disinfect them, but don't ruin them. Again, remember our goal. We want instruments and devices that are safe for the next patient, and we want to keep them in good operating, functional condition. And there it is. Reusable device items safe for the next patient, use methods and chemicals to preserve instrument function. Now here's a little cycle for instrument processing, quite actually a lot of information on this slide, and this is just the summary. We'll go through several steps. We'll start with point of use. We'll talk about why it's so important to start cleaning at point of use. We'll talk a little bit about transport, the cleaning process itself. We'll talk a little bit about the importance of rinsing, how rinsing is really, unfortunately, very ignored. Lubrication, very briefly, a little bit about drying. And as you see on this cycle, we're actually not going to address too much about packaging, monitoring, and sterilization. That's a whole nother topic for another hour or two of some presenters' time. So why should cleaning start at point of use? It's something that I know really all of you are probably already doing. You may not have thought of it that way, but cleaning starts at point of use by removing cements, adhesives, blood, little specks of materials. We get those off of our instruments as we go. And I think in dentistry, we have quite a routine for this because we're working in such a tiny space that we do have to get a lot of this material off. So it's really part of our routine, and we just want to have a little more conscious thought about how and why to do it. So cleaning starts at point of use because dried blood and soil does create biofilm. Even on tiny surfaces, biofilm will begin to form. This is a collection of the pathogenic organisms and the soil that forms like a glue on the surface. The other problem is that dried blood creates corrosion. You can see that on the carbon steel razor blades. One blade to the left has no blood. The blade to the right, we had put some blood on it, and this actually happened, the corrosion happened within minutes on this carbon steel razor blade. And then you have materials like dried cements and adhesives. As you all know, dental materials, by their nature, many of them are highly adhesive, so they're supposed to dry. But if you don't get them off your instruments, you're really in trouble. So at point of use, there are several strategies. We, of course, have talked about wiping those soils and cements off. The key thing here, the key point I'd like to remind everybody is safety. Use one-handed methods. Do not allow the operator, the dentist, the hygienist, whoever, to stick an instrument out and have somebody trying to wipe it off. Hopefully nobody's doing that anymore. Use one-handed methods. Have cotton rolls or other materials on the tray and fixated in a manner that you can actually do the wiping. If you're using any reusable suction devices, those should be flushed during the procedure, especially a long procedure. You know, most of our suction devices are single use at one end. And then immediately after the procedure, spray, soak, or cover using wet towels. And I'd like to clarify here that you cannot soak items and then transport them. You have to transport them first and then soak them. We never want to carry contaminated instruments in liquid. That's very unsafe. But the key thing here is the word immediately. It has to happen quickly, this process of spraying, soaking, or covering. So here's another quote from an IFU, an actual IFU. Point of use delay and reprocessing must be kept to a minimum to avoid contaminants drying, thereby making cleaning more difficult. This type of statement is on many, many instrument instructions for use. So what's a rationale for a spray type product as opposed to just wet towels or a liquid soak? Really the main thing is convenience. We haven't really done so much of this in dentistry, but I often say, especially to other dental hygienists, I dearly wish that I'd had sprays when I was doing clinical dental hygiene, because we are always in a rush. We'd get a case done, we'd have instruments on the tray, we have no time to process them. I could have sprayed them, covered them, and gone on to the next case and accumulated 2 or 3 trays, and if they'd been sprayed, they would have been protected. So the idea with these sprays is that they keep the soils moist. They typically should have anti-corrosives. They may or may not have enzymes. And all of this actually really helps. It's very quick and convenient to start your cleaning process. And it's especially important that you have a strategy, whatever it is, that you have a strategy if you have frequent delays. And this oftentimes happens in busy dental offices where there may be 3, 4, 5 dentists, but there's not an instrument processing technician. So even though in dentistry we might be very quick, and it's only 10 feet from the patient treatment area to the instrument processing area, that doesn't help if an instrument sit there in the instrument processing for 30 minutes, hour, 2 hours. So this is an important and very helpful procedure for dentistry to avoid dried soils from point of use to instrument processing. The other thing I would like to mention is that there are some devices that should not be sprayed. They might be wiped off, but they shouldn't be sprayed. And those would be electronic devices, typically also powered devices like dental handpieces. And of course, as always, look in the device IFUs, the instructions, to find out what the manufacturer recommends. So what about that transport process? Many of you could probably recite this in your sleep. This is from the bloodborne pathogens: puncture resistant, labeled or color coded, leak proof on the sides and bottom, in accordance with the requirements. So this is all from the bloodborne pathogen standard. So you know this. I personally, although there is sometimes not too much mention of lids, I really recommend lids. Definitely a dental instrument tray is not considered a transport device, just the plain tray. It doesn't have enough of a side to be protective of items rolling off. And the other item that we've got to quit using for transport is cassettes. Dental cassettes are not OSHA compliant for transport. And in fact, they actually can be more dangerous because items will stick out the sides or the bottom. Dental cassettes are wonderful, and they have many good qualities, but transport is not one of them. So our instrument processing area, I know that you are going to be hearing, or maybe have already heard a little bit about the instrument processing area and its design. So I will just say a couple of things. One is that instrument processing areas, if they are too small, it really creates a problem with your dirty to clean pattern because you will still have aerosols if your processing area is too small. So it's a patient and worker safety issue. But the other thing with instrument processing, if it's too small, is it's actually a productivity issue. So you have a nice big office, there's 4, 5, 6 dentists, boy, everybody's roaring along, and they kept the same instrument processing area. This is really not productive, and you need to have more space there for your instrument processing. I show some pictures here that show some barriers, and these are certainly better than nothing. But I will tell you that aerosols, as you well know, can travel. And the area where the ultrasonic and the sink in particular, if it's too close to the sterilization area, this is just not appropriate. The other thing I'd like to mention is with the improvement of our process with automated cleaning, I think all of you should think about ergonomics. So our ultrasonics, it would be nice to have our ultrasonics slightly lower, as you see to the right in that one group shot, that one larger area. The ultrasonics are lowered slightly, and then the automatic washers really ought to be raised slightly. You can see how she's bending over there. So the ergonomics of your instrument processing area is certainly an important factor, again, for both safety and for productivity. Now, this complex slide seeks to summarize the major factors, not every factor, but certainly the major factors of cleaning. Water is probably a poorly understood, or let's just say less attention is paid to the effect of water in the cleaning of instruments in dental areas. In the medical world, this is a big deal. Water quality is a really big deal. And it does affect cleaning because water will affect dosing, as we'll see in another slide. Chemicals are certainly an important part of cleaning. But ironically, although I represent a company that manufactures chemicals, I'm going to tell you that chemicals are not magic. And you can't just say, oh, well, the chemicals, as long as I have the right chemical, it'll all be clean. That's not true, because the other two factors are so important. No matter how great your chemicals are, you do have to do things the right way as the human factor, that you've set things up correctly. And there is always going to be an issue of mechanical force. No matter what it is you're cleaning, in some fashion or another, there's usually some issue of mechanical force that helps to ensure cleaning. So all four of these factors really play in to everything that you're doing with cleaning. So here's a few notes about water quality. Certainly not comprehensive. There are entire documents for water quality. So this is an extremely abbreviated review. But water quality, generally, as the water gets harder, over 150 parts per million, and if you live in a known hard water area where you see a lot of calcium in your bathroom or in other places, you know you have hard water. This will affect the water quality for your dental practice. And it will affect the ability of detergents to even clean. The hard water binds up some of the detergent and makes it less effective. So then you may have to increase dosing, at least slightly. And you may have to consult with the detergent manufacturer to find out if it is even okay to dose higher because of the hard water. And interestingly enough, if you use concentrated water-based disinfectants, hard water can also affect the dilution and effectiveness of concentrated disinfectants if the water is too hard. So that is a very important issue. The other thing about water, we know it's wonderful, it's very important for rinsing, but water is corrosive. And one of the things that we've really got to get away from is over soaking, soaking overnight, soaking for 1 to 2 to even 3 hours during the day. We leave things soaking, we finally get back to them. No matter what detergent you're using or anti-corrosive agents, that cannot overcome the power of water over time. So you really do need to be aware of that and look at where in your office you are overusing or over soaking, prolonged soaking. And then I would like to send out an endorsement for the use of better quality water for rinsing. Even if your water quality is pretty decent and you don't have super hard water, they have found real benefits from ADA research with using DI water for the final rinse. So this is something I think would be good to discuss and check out in your office and with your particular water quality. The use of DI water is not too difficult in dental practices because we tend to have smaller devices. If you have automatic washers in your dental practice, you may have to consult with the washer manufacturer to figure out if there are some systems that you can use to improve the water quality going into your automatic equipment. And there is an AMI document. This is not an ST79, this is a separate document, a technical report that is exclusively devoted to water quality, and that is available from AMI. So chemicals, like devices and instruments, they also have instructions. So chemicals have instructions for use, and the instructions are basically the label that's on the chemical. Now, some companies will also issue separate types of instructions or additional instructions to help out with special applications. And you can always call and ask your chemical manufacturer if you have questions, if you're not sure what their directions really are referring to, or if you feel something's missing, ask the chemical company. They should have technical specialists available to help you. And then another issue that I think is really important, this may sound a little self-serving for me to tell you should use medical grade detergents, but I will tell you that if you're using household detergents or you're using dishwash detergent to clean instruments, that is not appropriate. Those particular products may have too high of a pH, they may be too foamy, they might be corrosive. They are typically designed for other applications, not necessarily for instruments. Use medical grade detergents, dose them correctly. In general, most of your instrument IFUs are going to ask you to use a neutral pH detergent, but not all. You just have to read those instructions. Some, but not all products have anti-corrosives added to them. You have to ask and you have to look. If you overdose, more is better. That's actually a problem because detergents leave residue. And if it's too hard to rinse the residue off, that residue will bake onto your instruments in the course of sterilization. and then form layers over time. That's not good. So no overdosing. And also overdosing can lead to foaming, and foaming actually can inhibit cleaning when it's in the ultrasonic. I'd like to comment just a little bit about enzymatic versus non-enzymatic detergents. I know some offices use non-enzymatic detergent as a matter of economy because non-enzymatic detergent may be less expensive. But one thing I will tell you is that enzymes are a very gentle and yet very organic, but also a very effective cleaning tool that you might say. It's a type of chemical that is very mild and yet actually very effective, especially on organic soil. And that's what we have. We have blood and saliva and other materials, and that's what enzymes go after. It's also especially effective in an ultrasonic because the enzymes have time to work. Enzymes need just a little bit of time to work. So it's a great combination. So I would endorse that as being worth any minor extra cost that you might have with an enzymatic versus a non-enzymatic. And then most profoundly is the IFU, that is your device, may say that you have to use enzymatic detergent. It may specify that in the directions. So if it specifies it in the IFU, you need to use an enzymatic detergent. What about tablets and powders versus liquids? So tablets and powders are maybe less expensive, easier to store, cheaper to ship. So they certainly can be great types of chemicals. The thing that you need to remember is that powders and tablets must be fully dissolved in order to be effective. Be sure you look at the directions and find out the best way to dissolve these chemicals before they are going to actually be effective. And check out the instructions carefully about how that works. So tablets and powders can also sometimes leave residue, especially in harder water. So it's not that they're bad, it's just that there are some issues with making sure that they work properly for you. And then I'd like to comment on cleaning with alcohol. This is a tricky one because sometimes it's actually in your instructions for use. You may have a device that actually says clean with alcohol. One reason why this happens is because instructions for use may be written by an engineer. This is a person who knows nothing really about the cleaning process. They only know about their device. And they're using isopropyl alcohol as a fallback because they don't really know what else is out there. Isopropyl alcohol is really, or any type of alcohol over 50%, is really not a cleaner. It's a great disinfectant, possibly, depending on how it's prepared, but it's not a cleaner. Alcohol tends to denature protein. It will actually fixate it and make the blood and protein harder to remove if alcohol is applied before the item is clean. So if you have a device that says clean with alcohol, you may need to find out a strategy. Again, you have to call the manufacturer of the device and have some way to clean off the soil, especially if there's visible blood soil, that you have an appropriate strategy to get the blood off before applying alcohol. So how does my ultrasonic work? There's little transducers inside the chamber, as you can see, hidden. You don't typically see this. The transducers are transforming electrical energy to waves and then creating these little bubbles that actually implode. They're not exploding, they're imploding on the surface, and that actually pushes soils off. And this is ideal for small surfaces like dental instruments. So it's really an ideal cleaning device for a dental office. But that does have implications because if imploding bubbles are how your device works, that means that you really have to make sure that those bubbles are working. That means, number one, you make sure you have good, clean solution that you're starting with each day, that you degas, that is, get some of those extra bubbles out of the solution at the beginning of the day. Check your instructions on your ultrasonic on how to do that. And most importantly, you've got to keep items submerged. Don't overload, and make sure that the devices are in under the liquid. The little bubbles cannot implode on something that's sticking up above the water. So don't overload and keep the items submerged. This also kind of applies to using ponytail holders or sometimes plastic containers. Plastic tends to dampen the ultrasonic action, and ponytail holders, of course, are dangerous for sharp items and will keep things too cramped together so they can't all enjoy the activity of the ultrasonic. So don't overload, keep stuff underneath the water level. And here's the fun thing. I hate to put stuff out there that creates more work for everybody, but I'll tell you what, your ultrasonic is a biofilm factory. I will say it again. Your ultrasonic is a biofilm factory. It's making biofilm from the minute you turn it on till the end of the day. It's perfect. It's warm, plenty of liquid, and then you keep adding germs to it. So it's when you stop and think about it, it's pretty horrifying. So the ultrasonic needs to be emptied, cleaned out, and cleaned out mechanically as well as rinsed. That means some scrubbing action is required, because remember, biofilm is very sticky, all like glue. So you can't just rinse it out. You have to actually scrub it. It's kind of like the biofilm that forms the bottom of your kitchen sink. I personally hate this, but it is what it is. You keep adding germs, we keep adding water, and then we create biofilm. So anyway, that's just another thing to add to your list of stuff that you have to do. So we do know that there's ongoing ADA research. Some of it's been towards the efforts to help manufacturers with their cleaning instructions, and so that's really important. And out of that research, several tidbits. They certainly supported the effectiveness of enzyme pre-soaks, rinsing with distilled water, and of course they're the folks that are really pushing us to dry instruments completely prior to packaging and sterilization. And certainly we've heard that message from the CDC in their guidance as well. Dry the instruments. Now, I feel, from having been in dentistry, processed instruments myself for years, that asking people to dry instruments is really somewhat dangerous, because our typical strategy in the average dental office is to take various types of cloths and pat the instruments dry. And this is really dangerous for us to do that. So one thing I'm really advocating for is that dental offices look into the ability to install drying drawers in your instrument processing area. This is a drawer, it's actually an appliance, and it's just simply for drying. It has an active drying entity to it. And of course, your instrument or dental supply house will be able to help you with that. So drying drawers would eliminate that whole issue of getting stuck. Now, a very brief message about lubricants. Lubricants, of course, are not for all instruments. It's basically for your forceps and scissors and other jointed items. We previously have used milking and milk dip. And what this is using products with mineral oil that are then colored white to kind of conceal the droplets of mineral oil. And then you dip items into these little tanks of milk bath. And then you keep reusing that milk bath for days even. This is very inappropriate. It's a great avenue for cross-contamination. You're actually creating another biofilm farm with your lubricant. Mineral oil itself can actually be a barrier, potential barrier to steam sterilant. It can get a little bit sticky and build up in the box locks. So do look at your IFUs. Many of them do still refer to mineral oil as the preferred lubricant, but you do need to be careful about not over-applying it, and you might want to consider a spray instead of a dip-type bath. Now we're going to get into a little bit about measuring both our devices and our cleaning results. Measuring clean. So certainly magnification has definitely made it more dramatic for us to make sure that our instruments are clean. We really want to be focusing on patient safety. That's paramount. But it is also very embarrassing when someone's responsible for processing instruments and lo and behold, they see something on the instruments in the middle of a procedure with magnification. So there's so many reasons why we need to be checking what we're doing and checking the results of our cleaning process. There are two basic things we're trying to go after. We're trying to figure out if our devices are working correctly, but we're also trying to figure out if we have residual soil. So this particular slide is from a few years back, a project that was done with this particular device that is unfortunately somewhat expensive, but incredibly awesome. Residual protein detected by a fluorescent detection system. And you can see on the left image, not the ring itself, but over in what's actually the ridges, how fluoresced and yellow that is. That's a lot of blood soil, a lot of protein. Whereas when you look at the picture on the right in the circle, you see those little serrations of the needle holder, but you really can't see anything in there. So definitely there can be soils that are not easily detected visually, and that does present a problem. So let's talk about function testing first. Ultrasonic function testing should be fairly straightforward. And the main thing is noise does not equal cleaning. In other words, your ultrasonic is making all kinds of racket, but that doesn't mean that the transducers are actually producing the waves that will create the bubbles. So you do have to do function testing. Aluminum foil has been a tried and true method for years. I just ask you that if you do foil testing, do not use that as your cleaning solution. You need to discard the water or whatever was in there because you'll have particles of aluminum foil in that test solution. Probably at least monthly, or check your ultrasonic operating instructions for how often they recommend function testing. So again, that's very important to check function. And the aluminum foil pattern should be an even overall pattern of dimples and possibly some tiny holes, but it should be even and all over the entire sheet of foil. Other types of function testing, which are a little bit more objective, are commercially available. There's various types of strips, coupons. There's a little SonaCheck capsule thing. There's a strip that actually tests for both enzyme content as well as the sonication process itself. But these are all basically function tests. They don't test that your instruments are clean. They test that your device is working. Likewise with washer tests. They don't guarantee that your instruments are clean. What they are helping you do is figure out if your cleaning device, your washer, is actually working. I'm personally a fan of TOSI type tests that have fibrin as well as a color marker because they're more resistant, and they are really the true, what I would call gold standard for figuring out if your washer is working. There are other types and other brands of these colored dyes with various types of holders, and they measure both impingement and detergent action. Again, we see a product that also measures enzymatic activity. But I want to tell you, you can have passing tests, fabulous passing coupon tests, and still have dirty instruments. How can that happen? Because of the human factor. Remember that slide we saw earlier that had human factors on it? If humans are not loading the washers correctly, overcrowding or putting things in such a way as that they do not get the full cleaning action, then I don't care how many little tests you pass, the instruments themselves may not be clean because we didn't load them correctly. So loading is a big issue. Which brings me to surface soil test products. I'm really a fan, when you get into testing for cleaning, that you use both. Use function tests and use surface soil tests. My personal preference is swabs. I like the protein or hemoglobin test swabs. Hydrogen peroxide can also be used. It's kind of a homemade thing, and there are also products available, but definitely some type of swab. Do you need to do it every day? Not necessarily. You might choose a weekly or even a monthly audit. And then if you have bad results, you can step it up and do it more often until you get good results again. But you do need to do both soil tests and function tests. I'm not a particular fan of ATP, although there are many of these types of products available, simply because the ATP testing is not calibrated or standardized to any particular soil load. But they are something that you could use potentially to check for soil markers. So I'd like to take a little time here to review quick key takeaways from this program. Hopefully you're going to leave today's events with Beyond Clean because of the several speakers emphasizing device instructions. This can be overwhelming. Again, I recommend maybe start with 2 or 3 of your most expensive and most complicated devices. Look at the device instructions and verify that you're using the right chemicals and you're using the right process. Follow device instructions. Start pre-cleaning at point of use. If it's kind of a informal process at your office, make a thing out of it. Know for sure that everybody is doing this and that you have a plan for how to pre-clean and start at point of use. Figure out a plan for transport. Consider perhaps that these enzymatic sprays may be helpful to your office to help prevent biofilm and to preserve your instrument quality. Look at the chemicals you're using and make sure they're the right type of chemicals. Use and maintain your automated cleaning equipment. Consider rinsing with the best possible quality of water. And rinsing, period. Rinsing is really important. Consider how you're drying and trying to make drying safer. And if you have no cleaning testing, start somewhere. Do some cleaning testing, at least function testing, and consider those soil tests as a way to really bring up the quality and the assessment of your cleaning process. So with that, I'd like to turn it over to, hopefully we have a few minutes now for some questions, if there are any questions. I also would like to share with you my contact info. Your questions, emails are always welcome. It just so happens that I will actually be out of the office the week of September 13th. I don't want anybody to be discouraged if they call or email that I may not be in the office next week. But we certainly encourage you to call or email questions. They don't have to be related to Sertal products. We'll try to answer whatever we can for you.
All right. Thanks, Peggy. That was awesome. And
Thank you, Brett.
Full disclosure on my side, Peggy and I used to work together for almost 4 years. So I learned a lot from Peggy throughout a number of different travel expeditions, going to hospitals and sitting through educational seminars. And so, yeah, it was great to hear some of those points reiterated that you and I have spoken about numerous times. Mm-hmm. So we do have a couple of questions, and then I wanted to maybe get into a little bit more of an in-depth discussion since we have some time. But can we, here's a question here. Can we use enzymatic cleaners when instruments are adhered with cements?
Ooh, that's an excellent question. And it really has several parts to it. One is hopefully the person now knows that inorganic materials like cement, that the ideal removal is at point of use because unfortunately there really is no cleaning chemical and including enzymes. Enzymes will not have much effect on inorganic material like cements or adhesives. That's why it's so important to have point of use cleaning, the wiping off during the treatment. It's unfortunate that enzymes will not have, you can soak, but soaking, I've soaked stuff with cement on it. Ugh, it's horrifying. So the short answer is probably no. No, enzymes are not the best choice for cements. And if you get into more aggressive chemicals for cleaning off cements and adhesives, you will end up scratching and ruining the instruments, frankly, to get the cement off.
Right. Yep. Good point. So you talked about IFUs, and you and I have constantly had the conversation back and forth over the years about the importance of utilizing the IFUs and making sure that you're reading through them. But we've also run into the IFU side of where they're recommending the wrong chemistry. You know, I think, as you mentioned, engineers are sometimes developing these IFUs based on their knowledge of the instrumentation, the instrument makeup, the metals. And what would your suggestion be when you come across an IFU that is, I guess, blatantly wrong and not suggesting the right chemistry and causing more damage to the instrument itself and possibly making it more difficult for the hygienist or whoever's cleaning the instruments to actually work with it? I mean, it could even be a health hazard. I mean, I've seen some where they're recommending high-level disinfectants
Yes.
out of the gates.
It's still there.
So, yeah.
Yes.
So what would your
So,
recommendations be if you come across that and it's questionable?
so the first thing I do is check to make sure that you have the current instructions for use. Many of these companies, especially on the dental side, are scrambling and reissuing their IFUs. They're rewriting them and reissuing. Make sure that you have the most current version. And I'm not going to say it's easy. It can take way too much time to penetrate a company and find their technical support. It shouldn't be that difficult, but it is. But anyway, the first step is make sure you have the most recent version, because a new one could have been issued and maybe fixes some of those problems.
Okay. And what would your recommendation be for accessing IFUs and having those available on hand? Because realistically, they should be there to as a quick reference. And is there a good place to house them, or should there be a database somewhere? Do you recommend any specific process when it comes to that?
Well, the one that comes to mind is the one I happen to be familiar with, which is OneSource. OneSource is not cheap, but it's a really awesome database for finding IFUs. It's more cost effective probably for a larger institution, a dental school, a hospital, that kind of thing. So a smaller office is frankly a little bit left adrift. I would recommend going back to your salesperson, the person that sold you the device, especially the more expensive devices. Go back to your salesperson, make them do the dirty work for you. And the other place is, frankly, if we ever get to go back to live shows, go march up to the booths and the salespeople of the product that you purchased and kind of get a little bit in their face and say, I need to get the instructions. And how would I go about doing that? Because then you've got some more direct contact.
Right. Yep. And so speaking of sales people and vendors, and I've been on this side with you and doing in-service education and training, is it important for our vendors to be educated to where they are knowing the processes and not just the, say, for example, the chemicals? I think knowing what the dental hygienists are dealing with on a daily basis and knowing their challenges from, disinfecting a room to cleaning and everything, is it important for them to have a full wide range of knowledge for them to do these in-services?
So at a minimum, I would recommend from the vendor side that whether the person's involved in the manufacturing of the items, or more commonly probably the sales of those items, that at a minimum they should know their own device instructions backward and forward. That at a minimum they should know that. And then at a secondary level, if their company's selling other, especially infection control products, if they sell infection control products, they need to know infection control, period. But definitely at least their own product instructions. That's really what they've got to know that.
Yeah. And I've been in facilities, you've been in facilities where we've heard some questionable recommendations based off of IFUs. And I think, it is very critical to know what your product can do, what it can't do, and to also make sure that you're saying and telling the right things, especially when it comes to busy clinicians, because you're seen as a point of reference and they need to be able to trust you. So
now you're talking ethics. And
yep.
And I'm really sad about the fact that this should even have to be a topic of discussion, because knowledge is one thing, but you don't take ignorance and turn it into unethical behavior. I guess on the other hand, people can use the excuse, "Oh, I didn't know," but that's and like you said, you and I have both been in that situation where we've literally heard directly or indirectly a grossly inappropriate recommendation, and it was self-serving because it was to promote some product or whatever. So, yeah, I honestly, I don't know what to say about the ethics of it. It just, I do understand that some of it comes from ignorance, but there's too much at stake here. I don't care. People sometimes think, oh, well, it's just dentistry. It's not just dentistry, it's healthcare. I mean, people are trusting you. They're sitting in that chair and opening their little mouth and going, okay. And it really is shocking what people think is okay to say to vulnerable. I mean, I was in that position when I was teaching. Honestly, there were certain things I just didn't really understand about chemicals, and the sales rep told me such and such, and I believed him because we were busy. We had so many other things to take care of, and it's a real thing.
Yep. Yeah, with the whole thing with disinfectants, there's the misperception that disinfectants are cleaners, and also the misperception that detergents are disinfectants. So
yes,
and I think that there has to be a real clear line and also a very clear understanding of what the disinfectants do. Yes, they're meant to disinfect, and you talk about a surface. So when a surface isn't clean, and this would be my question to you, can it be adequately disinfected?
Oh, absolutely not. And there's two issues there. So one is you've got to get the soil out of the way to kill the germs, or at least to kill the germs completely. So the cleaning is essential. Whether you do it with two different products or one product, you've got to clean the crud off so you can get to the germs and do the actual killing. But the other issue is what's happening to the surface underneath. So no matter what process you use, are the chemicals compatible for that device or surface? And that's why I've kind of rested on my standard deal that I put into a lot of my programs now about you need to make it safe for the next patient, but you also have to not ruin the item in the process of making it safe. So it's two goals that you really constantly have to keep them both in mind. And does the chemical really achieve your goal? So it can be a great chemical, something that's really reliable and awesome and whatever, but it's not suitable or doesn't take care of that step that you're after. As you were saying, the cleaning. So yeah, you've got to clean the crud off in order to get at the germs. Yep.
Right. And then, then this kind of goes back to the IFU side of things, but then we've seen the IFUs saying to soak an instrument in disinfectant. And, you mentioned that the blood adheres much more tightly to instruments if, you're soaking in disinfectants. If you're seeing that in an office, how do you approach the clinician or hygienist? What would you say to them? And how would you steer them away from that type of practice? Like, what's the first step before disinfecting? Because it's not soaking. You need to clean it off first, and then do the adequate steps.
Well, that really should be the job of the instructions for use, the IFU.
Right.
Instead of getting into some arguments and maybe some really inappropriate discussion,
right.
You kind of depend on the document, the IFU, saying, oh, look, I see you use Hu-Friedy instruments. Oh, look at this instruction. It says blah, blah, blah. You should do this. You shouldn't do that. Now, sometimes the IFU will trip you up because the IFU will also say the wrong thing. But
right.
Anyway, at least it's a good place to start, because then it's not you arguing or making a case. It's the document and the manufacturer that's really making the case. And that way it might be received better. Let's put it that way. Because people get entrenched in certain methods or procedures or brands of chemicals. This certain thing is fabulous. We've always used it. We'll never change. And lo and behold, that's something that's been called out on the instructions for causing damage. So you don't want to be the bad guy necessarily. So you just hold up the IFU and say, look, oh, look at this.
Right.
So yeah, that's the way I would go.
Right. No, great advice. So I think we have time for one more kind of thought that I had swimming out there, because I was recently in a hospital, and this is sterile processing, but I think it goes for dental as well, because when you are designing an office, a brand new office, right? There needs to be consideration built in with the architecture to make sure that there's an adequate area for cleaning. Mm-hmm. And this hospital I was in was, it's a new hospital, but there were some missteps made in the design aspect. And so I would ask you, if there is, say, a new dental office being built, would it be good practice to speak or to actually involve somebody that's going to be in that office and cleaning those instruments? Is that something, to really line that space out so you've got enough area to work with, and it's a smooth process all the way around? Would you recommend that?
Absolutely. That the people that are working, and again, as I'd said earlier in this program, it's the ergonomics of it, it's the flow, and frankly, and this is probably the phrase that will resonate with dentists, it's the productivity. You're going to get more cases through, you get more instruments turned over faster if you have a well-designed space. So the productivity part of it is what resonates. But of course, really for the people, it's the safety and the practicality. So talk productivity, but you'll get safety.
Right. And then the aspect of time, you'll get faster turnaround times. Efficiency is just going to make everybody's lives better, and ultimately it's going to be safer for the patient. So
exactly.
Yep. Well, Peggy, I think we're out of time. It's been a pleasure. It's great to see you again. And thanks again for joining us. Everybody out there in virtual land, I just want to let you know that if you need to get in touch with Peggy, her contact information is up on the slide here, but we also have it below on your right side. I will actually highlight that for you right now. And again, if there are any questions we did not get to, we will make sure to send those along to Peggy. She'll willingly answer those. She did say she's going to be out next week, as am I, because I'm going to be getting married in a week. So I might not. I might
finally,
not.
Finally.
Yeah. Yep. So
I had to throw that in. Sorry.
Right. There you go. So yeah, we will make sure to pass along that information as time allows. But once again, Peggy, thanks. It's been a pleasure. Great information as always, and look forward to you joining us again soon.
Very good. Thank you, Brett.
All right. See ya.
Bye.